Okay, so we already reached for the final part of this video. So well done. I love your commitment. Okay, so make sure you complete the final parts. Alright, so you can conclude that you already completed for module 10. See ya. Okay everyone, now we are already in the final part of this module. So these are the objectives for this final video. I will differentiate the among physical transmission media and the wireless transmission media. Now let's start. Transmission media. Transmission media consists of materials or substances capable of carrying one or more communication signals. When you send data from a computer or mobile device, the signal that carries the data may travel over various transmission media. If you refer to figure 10.19, it illustrates the variety of transmission media, including both physical and wireless, used to complete a data request over the internet. First, let's look at broadband. Broadband media transmit multiple signals simultaneously. The amount of data, instruction, and information that can travel over transmission media sometimes is called the bandwidth. The higher the bandwidth, the more data can be transmitted. Next, let's discuss on latency. Latency is the time it takes a signal to travel from one location to another or a network. For best performance, bandwidth should be high and latency should be low. So this is an example of figure 10.19 that I explained to you before, where this figure shows a simplified example of sending a request over the internet using a variety of transmission media. Now let's focus on physical transmission media. Physical transmission media use wire, cable, and other tangible materials to send communication signals. These wires and cables typically are used underground or within or between buildings. Table 10.3, as you can see here, lists the transfer rates of LANs using various physical transmission media. Now, let's start with the first one, which is twisted pair cable. Twisted pair cable consists of one or more twisted pair wires bundled together. Each twisted pair wire consists of two separate insulated copper wires that are twisted together. The wires are twisted together to reduce noise, which is an electrical disturbance that can degrade communications. Next, we have coaxial cable. Coaxial cable consists of a single copper wire surrounded by at least three layers. First, an insulating material. Second, a woven or threaded metal. And third, a plastic outer coating, as you can see in figure 10.21 here. CATV network wiring often uses coaxial cable. Then we have fiber optic cable. The core of a fiber optic cable consists of dozens or hundreds of thin strands of glass or plastic that use light to transmit signals. Each strand, called an optical fiber, is as thin as a human hair. Inside the fiber optic cable, an insulating glass cladding and a protective coating surround each optical fiber, as you can see in figure 10.22. Fiber optic cables have many advantages over other cables. For example, it has the capability of carrying significantly more signal than wire cables. It can transmit faster data, less susceptible to noise. They have better security for signals and almost smaller size as compared to other cables. However, disadvantages of fiber optic cables are it costs more than twisted cable or coaxial cable and can be difficult to install and modify. Then let's move to wireless transmission media. Wireless transmission media send communication signal through the air or space. Many users opt for wireless transmission media because it is more convenient than installing cables. In addition to convenience, businesses use wireless transmission media in locations where it is impossible to install the cables. Table 10.4 lists the transfer rates of various wireless transmission media, which I will discuss after this. First, we have infrared. So infrared is a wireless transmission media that sends signal using infrared light wave. Mobile computers and devices such as a mouse, printer, and smartphones may have an IRDA port that enables the transfer of data from one device to another using infrared. Then we have a broadcast radio. Broadcast radio is a wireless transmission medium that distributes radio signals through the air over long distances such as between cities, regions, and countries, and short distances such as within an office or home. Then we have cellular radio. Cellular radio is a form of broadcast radio that is in wide use for mobile communications specifically wireless modems and mobile phones. Please refer figure 10.23. Several categories of cellular radio transmission exist, defining the development of cellular radio or cellular networks. Normally, it will start with 1G, followed by 2G, 3G. Now, we are in 4G and we are moving toward to 5G or 5th generation. Next is microwaves. Microwaves are radio waves that provide a high-speed signal transmission. Microwave transmission, often called fixed wireless, involves sending signals from one microwave station to another, as you can see in figure 10.24. A microwave station is an earth-based reflective dish that contains the antenna, transceivers, and other equipment necessary for microwave communications. Then let's look at communication satellite. A communication satellite is a space station that receives microwave signals from an earth-based station, amplifies the signals, and broadcasts the signals back over a wide area to any number of earth-based stations. So you can refer to figure 10.25 for example of communication satellites. Transmission from an earth-based station to satellite is an uplink, where transmission from a satellite to an earth-based station is a downlink. Next, we have GPS, or Global Positioning System. It is a navigation system that consists of one or more earth-based receivers that accept and analyze signals sent by satellite in order to determine the receiver's geographic location. So this is an example of how GPS works. So as a summary, this module presented a variety of networks and communication technologies. Okay, I'll also discuss the various types of network architectures and standards and protocol. In fact, I also explained the communication software and several types of communication lines and communications devices. Then I also discussed how to create a home network and presented the variety of physical transmission media and wireless transmission media. So that will be the end of the module 10. See you again in the next video for the next module. Bye.
Alhamdulillah, you already completed all the 4 videos for module 10. Then make sure you subscribe, like, and put some comment in my video for me to improve my lectures in future. Don't forget to hit the bell button so that you always keep in touch with me for the latest video in my channel. Okay, Assalamualaikum. See you again for the next video. Bye.